What's going on, guys? Mr. Jones coming at you once again. We're finally going to get off the quadratic train. Hopefully you're excited to hear that. But what that means is that we're going to do something totally different. But we need to go back to some prior knowledge. So hopefully we went over in the warm-up graphing lines by looking at an equation, because you're definitely going to need to know how to do that for this task. So that's the problem with math, is that math always builds on itself. So you're always going to need things that you learned in previous years. All right, this task is a develop understanding task. That usually means it's going to be a little bit difficult. And so don't expect to get a whole bunch out of this task, but you will learn a couple new things for sure. But this is part of the learning experience. So here we go. Part 1. Connect context and graphical representation. Sorry if I could read, right? So here we go. Create a story that matches the graph below. So that's what we're going to do, is we're going to create a story. Whatever you want your story to be about, it just needs to match the graph. When the graph goes up, it needs to be true in your story. And whenever the graph goes down, it needs to be true in your story. Okay? You have to label the axes and be as specific as possible in describing what is happening to connect your story to your graph. So what does it mean whenever it says label your axes? So hopefully you already know this is your x-axis over here, and this is your y-axis, right? If I can write here, let's fix that y. There we go. But that is not what it means. It means tell me what your axes represent. Right? So right off the bat, just to kind of give you an idea of how to get started, one of the easiest things, and a lot of times with the x-axis, is it's related in time. So you can use time of any sort. I'm going to make my story in hours, okay? In hours. But you can make it minutes, seconds, and it can be anything that really doesn't change. But time is a good one for x. Your y, your story needs to be whatever is changing. So for example, if your graph is going up and to the right, time is always passing. So you notice the graph is always moving from left to right. And first of all, you always read your graph from left to right, okay? But if we start off here, what does that mean? If my graph goes up, what does the y-axis represent? Okay, that's causing the graph to go up. So right now, go ahead and take a look at this graph. Label your x-axis and y-axis. Okay, you could use time for x if you wish, but make your own y-axis and think of a story that you could use to go along with this graph. Okay, it doesn't have to be perfect, but it does need to be a story to go along with this graph. Okay, so hopefully you've paused it. You've attempted to write a story that goes along with your graph that's going to be different from everyone else. Now, it says if you were to write a function to match each part of your story, how many would you write? Okay, so think about that. If you had to write an equation to match each different part of your story, where does something different always happen in your story, right? All right, so let's answer both of those questions. Hopefully you've had a time to answer those questions. But here's what my random story would look like, and hopefully yours looks very different. So I don't expect you to have the same exact story, but I do expect you guys to write your story. Okay, that's the whole point. It says create a story. I want you guys to actually create a story. So you should have a nice paragraph there. You can type it up if you want. But my story goes like this. So first of all, I want this side to be miles. Okay. Miles. So my y-axis is miles, and my x-axis is time in hours. All right, so just for fun, my story goes like this. And I'll show you how it relates to the graph, right? So in the beginning, there was Timmy the tortoise. Timmy the tortoise decided he wanted to go for a walk. He needed to get some exercise. He just didn't know what kind of trouble he was about to get into. Okay, so Timmy goes along at a distance of 1 mile an hour. So every hour, you notice, that was the slope of this line, by the way, he travels at a constant speed of 1 mile per hour for 5 hours. Okay, Timmy gets tired. He's been walking for 5 miles and it took him 5 hours. Okay, notice hours is X and that's 5. And miles is Y and that's 5. So he walked for 5 miles and it took him 5 hours. That's how that relates to my story. But now my graph gets flat, right? So my graph now doesn't go up at all, which means he's not traveling any miles, but time is still passing. So this distance, 5 hours passed because he took a nap. He was tired, right? He was so tired. He didn't sleep very good the night before. He took a nap. He didn't go anywhere. But then he woke up 5 hours later, realizing his nap was way longer than he wanted it to be. And he decided that he needed to hurry the heck up. So you can see now that I have a steeper line, which means he's traveling at a faster speed, right? In fact, his slope here is 2 over 1, which means he's traveling at a rate of 2 miles an hour, right? And he goes all the way here. He goes for another 5 hours. So for 5 hours, he travels at 2 miles an hour until he reaches a distance of now 15 miles away from his original starting point. Okay, so look at the point 15, 15. 15 for X means 15 hours, and 15 for Y means 15 miles. So far, this trip has taken 15 hours, and he's gone 15 miles. But once he gets there, he realizes, oh my gosh, I ran so fast. Silly me, I literally ran past where I was trying to go. So he had to backtrack. Okay, so that's this downward slope here. It's saying that his miles went down. How do you go negative miles? That must mean miles from home, right? So he went backwards, and now he's going at 1 mile an hour again because he's tired from going 2 miles an hour. So for 5 more hours, it took him at 1 mile an hour. That's how long it took him to go backwards 5 miles. Okay, so he ended up being, if you look at this ending spot, it ended up taking him 20 hours, but he only got 10 miles away from home. And that's what that point would mean. Hours, miles, right? That's how long his trip took in hours. And 10 was the amount of miles he went. So there's my random story, right? And hopefully yours was very different than mine. The next question was, if you were to write a function to match each part of the story, how many would you have to write? Well, every time the line changes, that's a new function, right? So here would be a function, 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 right? Hopefully you guys realize you're going to have 4 equations, right? And now we get down to the good part. Identify and write the function and corresponding domain for each section of the graph. What the heck does domain mean? Domain means all possible x values. If you don't know that, get that. All possible x values, okay? So that means, and I'm going to do the first one for you, and then you guys can do the rest, right? You guys can figure out the rest. So it gives you the format there that you're going to have all 4 functions happening at the same time. So instead of just saying y equals and putting it in front of every equation, they're putting it in front of all equations at the same time. Okay? You can see over here in the problem that you put your function on the left, so that's the rest of the equation, and then all the x values that it covers on the right, with a comma in between. So I'm going to show you this first one right here for this very first graph, okay? So writing this graph from here to here. Okay, we already know what the domain is, but I'm going to write it from left to right, so let's go ahead and put the function first. Let's get the equation. Okay, what's the y-intercept of that graph? Okay, that's a good one, the y-intercept of that graph. So it's 0, right? So we know if we write it in the form y equals mx plus b, it's going to be mx something x plus 0. Okay, but if you put plus 0, you don't actually have to put the 0. So you could just get rid of it. So it's literally y equals mx. So what's my slope? Rise 1, run 1, rise 1, run 1, rise 1, run 1. My slope is just 1. Okay? So guess what? The equation of the line from here to here is just f of x equals x, or y equals x. Now put your comma, and now you have to tell me on what domain, what x values does it cover, right? So lowest x value, right? Lowest to highest, right? Okay, so you're going to say with my lowest x value is 0, and then you have to put is less than or equal to x is less than or equal to whatever your highest x value is, which is 5. So we're just saying everything from 0 to 5, with 0 and 5 being included because we have those equal signs. And we know that because we don't have open dots, right? So you guys should have learned that last year in IM1, that if you have closed dots, it means it's included. And if it's an open dot, it means it's not included, right? So now your job is to go through for the rest of the points. And you know they're going to have 3 more equations, right? So create an equation for this line, create an equation for this line, and create an equation for this line. And just recall the start and the stop points, and remember that your numbers go from lowest to highest x value, right? And the format should look just like this. Okay, so go ahead and give it a shot, and then we'll talk about what your answers could have been. So go ahead and pause the video, please, and give these a shot on your own, guys. You'll get more out of it, I promise. All right, so here's the answers that I got for all 4 equations. I'm just going to briefly go over them. So we already went over the first one. Okay, remember the first one, the equation was y equals 1x plus 0, but these both disappear. Okay, the second equation is just this horizontal line. So this is equation number 2 up here, and that's just y equals 5. Okay, so y equals 5, or f of x equals 5. And that goes from 5 to 10, right? So from x equals 5 to x equals 10. The next one goes from x equals 10 to 15. So that's from here to here, right? And now we had to use a point slope form. So this shouldn't have been, this is not negative. That's just a random line. Positive 2x minus 15 is the equation on that one. How did we get that? I chose a random point, so you could choose whatever you want, but the point slope, y minus y1. Okay, so y1 could have been 5 equals m times x minus x1, which you could have used 10. Either point would have worked. So I just used this point right here. Okay, plugged in my y and x value. And then I converted this, so I just moved the 5 to the other side. So I called this y equals, and m, my slope is 2 over 1, 2 over 1, 2 over 1. So I know my slope is 2, and I just added 5 to both sides, right? Just like we did in the warm-up. And then you distribute, so y equals 2 times x, so 2x minus 20 plus 5. And whenever these combined, we got the 15 that you see over here. All right, same thing with the bottom one. I'll just save you that one, but this one was negative x plus 30. The slope was negative because we're going downhill this time, right? And then 30 ends up being the y-intercept on that. Slope down 1 over 1, down 1 over 1, down 1 over 1. So we knew the slope was negative 1, and that's how we got that. All right, the last section should be fairly quick. Basically, question number 4 says, make connections between the graph, functions, and context. I think it just wants you to realize that, hey, if my graph went up faster, had a steeper slope, then I was traveling faster, kind of how I talked about with the tortoise, right? And if I went downhill, I must have been going negative miles to some degree and so forth, right? So I don't think you have to write anything for number 4 because we already kind of talked about it. All right, so let's do this. The function you created above is called a piecewise function, all right? So this could go in your vocab. Piecewise function, you can see it written there on the left. In mathematics, a piecewise defined function is a function defined by more than one subfunction or piece of a function, with each section only existing in a certain interval of the function's domain. So we saw that we had 4 equations, and those 4 equations only were happening at a certain time. Once you move to a different x value, all of a sudden we were looking at a different equation. Okay, so numbers 5 through 7 is now just saying the solve function notation. So find f of 12. So remember, this means plug in 12 for all the x's. But remember, it says you have to use the correct function. Which function has an x value of 12? So come over here to this that you made earlier and look where 12 falls. Okay, so which function are you going to use, right? Think about that. Hopefully you see right here from 10 to 15, 12 falls in there, so you're going to use the function 2x minus 15. So you're going to plug that 12 in the f of 12 into the x's, and then you're going to get your answer. Okay? Then so I gave you the answer for number 6 already, and you should be able to solve number 5. And number 7 just says solve the rest. So this is the same as the previous one. And remember, this means that your y value is 3. Right? So if your y value is 3, you have to actually solve for x on these ones, right? So you can look on your graph and say, hey, where is my y value 3? And you can actually go find the corresponding x value. For example, let's look at this graph. Let's say that I said f of x equals 9. Okay, oops, that moved kind of a lot further than I was hoping. Let's say it said f of x equals 9. If I can ever get this to work right, we'll be in good shape. Okay, random problem, x equals blank. Okay, f of x is my y value, so this is y, or f of x. Okay, so if it's 9, it's right here. If you go over to the graph, it's right here. And whatever this answer is something comma 9. Okay, what is that something? 10, 11, 12, right? 12 comma 9. So the answer there would be 12. All right, guys, video is long enough. I think you guys get the picture. Make sure you guys get this turned in. Have a great day. Bye.